All right, it's Mr. Burkhardt again, and we are on 10H, the Doppler effect. So the Doppler effect is this phenomena where your perception of a frequency depends on your speed relative to the speed of the thing making the noise. And so the Doppler shift is often introduced in the sound unit because you can experience the Doppler shift directly with your ears. It's very easy to get it because you can hear a Doppler shift, a sound wave, Doppler shifting, and you've already heard it many times in your life, and maybe you didn't know that's what it was, but you've heard it. Everybody's heard a Doppler shift before. And so, you know what? Actually, I have a video for that too, since I already have it open. We might as well just go over here and grab that video. The touch screen is touchy. One of these days, I'm going to get ready before I start these videos. What are you doing? Oh, yeah, that's what I wanted. Hurry up. I'm sorry about that. So, how was your day? Talk amongst yourselves. I'm going to check my email while I'm waiting. That's probably not a good idea. Oh my God. Yeah. Well, it's not raining. This is totally not going to be worth it. Just wait. All right, let's see what happens when I open this one. I hope this is the right one. These are some college students who, for a project, decided to make some videos of the Doppler shift. So here's what it sounds like. Oh, so this is when you're inside the car driving and blowing your horn. Listen. I guess I did pick the right one. So it just sounded like a horn blowing, right? And did you see the person standing on the side of the road? I hope you did. Here's what it sounds like to the person standing on the side of the road. Doppler shift. Same car, same thing. There were three people with cameras. Here's the guy on the side of the road. You can hear the car horn sounded like it got lower when it drove past. It sounded like it was high, then it got low when it drove past. And finally, did you notice that there was a car driving towards? Wish I had not hit that arrow. That was not the right arrow. Didn't let me really. Well, I guess it didn't take me back as far as the last time. And what does it sound like inside the other car? Pause the video, talk amongst yourselves. And there's some random video with a weird name. Probably not going to open that while I'm making this video. Don't know what it is. I'm sure it's fine. I don't do anything evil. In fact, I'm going to do it just to prove it. All right. You hear that Doppler shift? That was some Doppler shifting going on there. Severe, even more Doppler shifting because both objects were moving. What's this? Is this Doppler shift? It's the ocean. Okay. Oops. That was supposed to be for fun, I guess, to make us crack up because it made me crack up. That's hilarious. All right, let's get back to the lesson. Where is it? All right, so we have 4 ambulances, and they are all racing up behind a bug. And in the top one, the bug is driving away, so the difference in their speeds is 10. In the second one, they're driving towards each other, so the difference in their speeds is 20 relative to each other. And then in the third one, the difference in their speeds is 10. And in the fourth one, the difference in their speeds is 0. They're driving at the same speed. So the highest frequency, so what's happening is these high frequency is measured by a passenger in the car. They're saying B is the highest. That makes sense. They're driving towards each other. So it's when you're Doppler shifting, your wavelengths, your waves are getting squished together because of the movement of the two things. And so that would squish the wavelengths together the closest when they're moving towards each other. So B should be greater, and then A, and then D, and then C is the lowest. That's because, so in A is the next because their ambulance is approaching the car slower, but it's still approaching. When they're approaching each other, it's higher. When they're moving apart, it's lower. And so D, again, that the passenger's going to actually just hear the regular sound. If they're traveling at the same speed, it won't Doppler shift. It's just as if they were both sitting still. And then for C, the car is actually moving away from the ambulance, so it's actually going to hear a lower note than the actual siren. In which cases would the passenger hear a higher pitch? That would be A and B when they're moving towards each other. And lower pitch is C because they're moving away from each other, and it's the same pitch. I just covered all of that. The relationship between speed, frequency, and wavelength. H, I, J. I think J is as far as we're going, right? Nope. I don't know. Is there more next week? I don't know. Let's just stop the video. That's enough. I forgot where I was. I talked about this. So that's H. Okay.